In our previous videos, we saw that when a Zener and a transistor are used together to regulate output, power loss of the Zener and the transistor is maximum at maximum input and maximum load. To reduce the Zener loss, we use op-amp. I am Reshma, and in this video, we will see how we can use a Zener op-amp as a voltage regulator. Today, we will learn about Zener op-amp voltage regulator, Zener op-amp voltage regulator and its power losses, Zener transistor versus Zener op-amp voltage regulators. We have noticed that when we control the base current of a transistor, we can regulate the output voltage. This means if we sense the output voltage and compare it with a reference, that is the required output voltage, then we get the error we are at. If we pass this error through a PI block, the output obtained can act as a control signal for the base current of the transistor. Now, the base current changes with respect to this control signal. As the base current changes, we can expect a regulated output. If the output voltage is falling, then we get a positive error. This causes the PI block to give the control signal to increase the base current. If the output is increasing beyond the reference, then we get a negative error. This causes the PI block to give a control signal to decrease the base current. With this setup, the output is regulated to the reference. Let us assume we need 5 volt output. So, here our reference will be 5 volts. For this, let us use a 5 volt Zener to regulate the reference. We can bias the Zener with a series resistor Rs to generate 5 volt at all times. We can use an op-amp to build the error and the PI blocks. The output of the op-amp can directly drive the base current of the transistor to regulate the output voltage. The op-amp is biased by the input voltage as shown. This way, we can regulate the output voltage. Let us now look at the power loss. If the gain of the transistor beta is high, then IB will be small compared to IC. So, IB can be ignored. And for all practical conditions, we can consider IE is equal to IC. We know that the loss in the transistor is PCE plus PBE. As we are assuming the base current is less, we can ignore the power loss of PBE. Hence, transistor power loss is mainly equal to VCE into IC. Let us now generate a table with maximum input and minimum and maximum load, and minimum input with minimum and maximum load. We can see that more power loss happens in the transistor. This is mainly dependent on input voltage and load current, and maximum loss is observed in maximum input voltage and maximum load current. Let us compare Zener transistor and Zener op-amp voltage regulators. A Zener transistor is easy to build, however, a Zener op-amp is more complicated. A Zener transistor needs lesser components, but a Zener op-amp has more active components. Loss is contributed by all the components in a Zener transistor. In Zener op-amp, loss is mainly contributed by the transistor. A Zener transistor is more suitable for low power applications. However, a Zener op-amp is suitable for medium power applications. In this video, we saw how we can use a Zener op-amp voltage regulators. We also saw how different it is from a Zener transistor regulator. This forms a basis of linear regulators. We will learn more in our subsequent videos. Till then, let's keep exploring and learning. Thank you.